What up, mathletes? Whoop, whoop. All right, this is Math 2 Mod 3. Welcome to Module 3, 3.1 Dilations. Please write down your learning target, which is I will draw and analyze dilated figures using tools or functions. Gotta admit, not my best handwriting, so sorry. But nevertheless, go ahead and do your warm-up. Take just a minute while I drink my, oh, you think it's coffee, but it's tomato soup. Campbell's. Good. Not a sponsored video, just like it. Okay, so I'm assuming you paused this, you went with it, laughed at my joke, it was awesome. We're just simplifying these guys. So what goes in both 15 and 81? Well, in this case, we know that it's 3. So divided by 3, boom, equals 5. Divided by 3, boom. Let's see, it goes in there twice, leaves 21. I'm going to say 21, 27. There we go. That looks right. Right? Awesome. Okay. Let's go with next. What do we got here? 36 and 216 turns out. Now you can go through doing a whole bunch of simplifications, but it's really going to be divided by 36. Divided by 36. And 36 divided by 36 is 1. 216 divided by 36 is 6. Boom. Okay, 95 divided by 240. Both of those, that one ends in a 5, that ends in a 0. These are divisible by 5. So 95 divided by 5 is 19. 240 divided by 5, 5 goes into 24, 4 times. It's 4 and a 0, that's 8. 48. Boom. Okay, 51 and 540. How do we do this? Well, they're both divisible by 3. How do I know that? 5 plus 1 is 6. Did you know you can add the digits together, and if your answer is divisible by 3, so is the whole answer. 5 plus 4 is 9. 9 is divisible by 3, so they're both divisible by 3. Boom. Little shortcuts. So 3 goes into 51 17 times, and 3 goes into 540 180 times. Boom. Forgot to square all my answers. And last, 189 and 300, same deal. I'm going to add those together. 1 plus 8 plus 9 is 18. 3 goes into 18. Same trick works for 9. 9 goes into 18. But we see 300 is just 3 plus 0 or 3. 9 doesn't go into 3, but 3 goes into 3. So both are divisible by 3. Lots of divisible by 3s today, man. So this is going to end up equaling 63 over 100. Boom. Okay, I've got some vocab for you guys to write down. Pause this if you need to. I'm going to keep moving on. Non-rigid motion, a transformation that changes the dimensions of a given figure. Okay, that's what we're doing today. We're doing some non-rigid motion called a dilation. A non-rigid motion that enlarges or reduces a geometric figure. So in this case, we're going to enlarge, or if we started here, we would reduce. Center of dilation is the center point. This is the center of dilation. This is the COD, center of dilation right here, okay? And we see this is the dilation being done, right? This is the center point from which dilations are performed, and the scale factor of the dilation is the ratio of the length on the image. The image, like an image in a mirror, it's the reflection. So we started out with ABC, this is the image. And this is called the pre-image. It's what you started with. Okay? And you'll notice, it's kind of hard to see, but each of these has a little tick mark above them on the image. That's because A maps to A prime. You call that A prime. B maps to B prime. C maps to C prime. Okay? All right. Take a minute, write these down, pause this as needed. And let's go on. Okay. Boom. It says triangle ABC to triangle DEF. So we started with ABC and we are dilating it to DEF. Notice we're getting it smaller. When it's smaller, your scale factor is going to be between 0. It's I said that wrong. Going to be between 0 and 1, so it's going to make it smaller. It's going to be a fraction. When it's making it bigger, so this is for smaller. For larger, it's going to be greater than 1. Okay? We don't really use 1 or 0 because 1 just keeps it the same and 0 makes it nothing. Okay, so let's look at this. Remember, what does it say? It says the dilation, or scale factor of a dilation, is the ratio, so it's going to be a ratio, so we're going to set out a fraction bar right here, of a length on the image. So remember, this is the image right here. It's what we just did. The length on the image is 2. To corresponding length on the preimage. What does DE map to? It maps to AB, which was 6. So 2 over 6, which that simplifies to 1/3. And since we know it makes it smaller, it should be a fraction between 0 and 1. It's a fraction. Boom. Voila. There we are. All right, determine whether the dilation from triangle ABC to triangle, so ABC is the preimage, and PQR is the image, is an enlargement or a reduction. Well, if we're going from ABC, clearly PQR is a enlargement. And what's the scale? Well, remember, what is it again? Is the ratio of the length on the image, so let's go to the image, which is 6, divided by the corresponding length on the preimage, which is 4. And that simplifies, 2 goes into both. That simplifies to 3/2, which is 1.5. Either one would work. Kind of got that one, didn't I? So 1.5 or 3/2. And that makes sense. It's 1.5 times, each one is 1.5 times larger. Okay? Awesome. Let's check this one out. By what percent should Jalal enlarge his design so that the dimensions of the banner are 5 times that of the original design? Well, what's 5 times 100%? Equals 500%. So we're going to make it 500% larger. And then it says, what will the dimensions of the new banner be? Well, let's multiply each of the dimensions by 5. 5 times 6 equals 30 inches. And 5 times 14 will equal, what, 50 and 20? 70 inches. So let's answer this. The banner will be increased by 500% with dimensions (30 inches by 70 inches. Boom. Look at that. Okay, and our last one today is just a little box to fill in about dimensions on the coordinate plane. So let's look at that. It says to dilate a figure by a scale factor of k with respect to the center of the dilation 0, 0, multiply the x and y coordinates of each vertex by k. So in other words, xy goes to kx, ky. The image of triangle PQR is dilated by k equals 3, which is mapped to triangle P prime, Q prime, R prime. Okay? All right. So we notice this right here had a coordinate of, we're going to do this example below where we have some space. So PQR, triangle PQR, see, point P was 1, 1, 2, 3, 1, 3. Point Q was 1, 1. And point R is 2, 1. I'm just counting over 1, 2, 1 to get the label of the vertex there, right? Point P, Q, and R. And it tells us to enlarge it by a scale factor of 3. That means to get to P prime, I should have 3 times 1 and 3 times 3. Therefore, P prime is 3, 9. That's the new point. And let's do it with all of them. Q, to get to Q prime, right? It's going to be 3 times 1, 3 times 1, or the point Q prime, 3, 3. And last, to get from R to R prime, we're going to have 3 times 2 and 3 times 1, because it's a scale factor of 3, right? I forgot to write that, K equals 3. Then it's going to be R prime, 6, 3. And let's see if this works. So P prime is 3, 9. So that's 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Look right there. Q prime is 3, 3. So that's 1, 2, 3. 1, 2, 3. Boom, right there. And last is 6, 3. 3, 4, 5, 6. 1, 2, 3. Boom. See how that works, guys? Easy peasy lemon squeezy. With that said, peace out.